It would be one of the most complex machines ever built. It would take 10,000 people and nearly 5 years to build it. It would cost an estimated $5 billion. Success was anything but certain. The plane would contain more than 4 million parts supplied by contractors around the world. But would they arrive on time?
Miss your first commitment and then things start to go wrong.
And would they work?
From a technical point of view, I would not put this back on the airplane if I had a choice.
Nothing could be left to chance.
154.
This would be the most tested airliner in aviation history. Eventually, lives would be at stake.
There's an apprehension anytime you change technology.
To make it all work, the company would reinvent itself from the inside out. And all of this would have to happen at a time when the world's airline industry was in recession. If the 777 were to fail, the company's future was at risk. Success would keep Boeing ahead of the competition for decades to come. This plane would be built to set a new standard for commercial aviation. This is the story of the building of a 21st century jet.
I'm sorry.
300 people are boarding a flight from London to Washington, D.C. It's actually an inaugural flight, although most of these people didn't know it when they bought their tickets.
This just happened to be the day we needed to go back to Washington, and the secretary made the flight. I don't think she knew it was the inaugural flight, so just pure coincidence.
This is the first commercial flight by United Airlines of a brand new airliner, the Boeing 777. The chances are that anyone who travels to Europe or Asia will sooner or later fly in the 777, as this plane replaces the older 747s on many overseas flights. It's Boeing's 7th new airliner, and the company has staked its future on it. In economic hard times for the airline industry, Boeing hopes the 777 will keep the company prosperous well into the 21st century.
To put it on, slip it over your head.
But the investment and the risk are enormous. For the last 3 years, we've been following the process of designing, manufacturing, and testing the world's largest and newest twin-engine airliner. It's cost an estimated $5 billion. Boeing needs to sell 200 or so planes at roughly $100 million apiece before the company will consider the plane a success. Back in mid-1992, Boeing began assembling and training the 10,000-strong team whose excitement and disappointments would punctuate the complex process of plane making.
How are you?
A key figure in this drama was Alan Mullally, the 777 director of engineering. He had a boyish charisma, a fierce pride in his company, and he was determined that the new plane would succeed.
Best airplane company in the world.
But in the time since Boeing had developed its last airliner, the aviation industry had changed. It had become harder to hold on to a share of the market.
What's different with the airlines? They have choices. They have choices. They haven't had so many choices before. All except the 747, Airbus has an airplane that can match every one of the Boeing airplanes. So they have choices for the first time in history.
This new competition had come about because of a gap that opened up in the commercial aviation market. The airlines wanted a long-range plane that was smaller than Boeing's 747, so Boeing's two rivals started manufacturing new planes to fill that gap. Airbus with its A330 and 340, and McDonnell Douglas with the MD 11 and 12. The 777 comes somewhere between a 767, a 200-seater, and a 747, which can carry up to 425 passengers. When the company first decided to enter the race, they hoped they could expand the 767 in ways that would satisfy their customers. Boeing took these designs to various airlines. No one was impressed. British Airways, for example, dubbed this a chipolata sausage. In October 1988, the design team met with Boeing's senior executives.
We had, at that time, I think, 7 product scenarios, all focused on a 767 derivative. And at the end of that 5-hour meeting, the simple question was asked, why haven't you looked at a new airplane? And our answer was, we really haven't done it yet. We'll go do the homework. And the next question was, when can we look at some data? And the answer was the last day before Christmas break in 1988. So we went back to our team, which at this time was about 200 people, and said, let's start working on a new airplane.
Boeing had done all this before. From its base in and around Seattle, the company had designed and built 6 different airplanes for the world's airlines. By the end of 1988, they had decided it was time for a 7th, in spite of the huge financial risk this involved. And the risk would increase over the following years as the world moved deeper into economic recession. When President Clinton visited the Boeing plant early in 1993, he reminded the assembled workers of how bad things were for the airline industry.
And it is indeed ironic that the United States, which for so long has led the world in the production of airplanes, has had 3 years in which more money has been lost than was made in the previous history of the airline industry.
The economic situation would prove a constant source of anxiety for the plane makers as they got underway on the 777. Particularly for the executive in charge.
I was a young engineer here in 1969 when 2/3 of the Boeing population left during the period when there was a big sign outside that said, outside of Seattle, that said, last person out, please turn out the lights. That clearly has affected the way I think about organizations and stability of organizations. Be more careful when you're going up, because on the other side of up is always down. We went up way too fast. We weren't efficient in the process, and so when we got to the top, we were way overmanned, and the far side was very steep. Don't want to ever do that again.
To justify the huge investment in the new plane, Boeing needed a launch customer, an airline that would commit to buying a significant number of the new planes in advance. They naturally turned to United Airlines. The two companies had been partners in the early days of commercial aviation. This is United's first Boeing airplane, the earliest all-metal transcontinental passenger airliner. The company has since bought more than 1,000 Boeing airplanes. But the historical relationship between the two companies counted for little when it came time to make the deal. Gordon McKinsey of United.
So we went through a rather large evaluation process in 1989 and 1990, where we were looking at 33 combinations of airplanes and engines for our wide-body purchase. And this was just one of the candidates. The 777 was up against the Airbus and the McDonnell Douglas airplanes.
The sales campaign came to a head on the weekend of October 13th, 1990, when all 3 manufacturers, Boeing, Airbus, and McDonnell Douglas, were summoned to United headquarters in Chicago to make their pitches. Boeing was asked to sign this handwritten piece of paper, It played a crucial role in the decision, as Alan Mullally would later tell the 777 team.
There's a piece of paper that Jim Guyette, who's Executive Vice President of United Airlines, wrote at 2:15 in the morning. He woke up in a cold sweat. He's going to walk in and see Mr. Wolf, who's the chairman of the board of United. He had the chief financial officer that was voting for Airbus instead of Boeing, and he had to walk in and make his vote. What airplane should United Airlines go with for the next 30 years?
It was a hard-headed and unsentimental business, with each of the three competitors in separate rooms, running in and out of a room full of senior United executives who were trying to make up their minds. An executive named Dick Albrecht led the Boeing sales force. Phil Condit, as leader of the 777 team, wondered whether he should go to Chicago too.
I talked to Dick Albrecht, said, you know, do you need me there? And his answer, and I believe correctly, was no, I think we've got our pieces, we'll go try to put the deal together. So I said, okay, well, here's my phone number. I'm gonna be at my younger daughter's parents' weekend at Colgate University. And I'm available by phone. I'll check in.
Well, it was emotional because when we went in there, I think it was a Thursday morning, we were told by the senior VP of Finance that we weren't leaving that building until the deal was done. So we'd all checked into local hotels, and we were there watching the sun rise over our corporate headquarters twice.
After a while, I was reasonably certain that the phone was probably broken because it didn't ring. Sitting there watching it, nothing happened. So I called Chicago. And they said, we're just sitting here, but we expect something in the next couple hours.
You know, we went into 70 hours of nonstop negotiations. And it was very emotional because we could tell by the faces on the people coming out of the Inquisition chamber that things had not gone well. You know, what was happening, of course, is, you know, somebody would go in there from one manufacturer, and a deal would be presented, and then he would be dismissed, and the next person would come in, would try to better the deal. So it was a ratcheting process through those 70 hours, trying to get the best terms.
So finally, at the end of the day, things were still sort of about to happen. I said, I can't stand this any longer. I got on the airplane, went to Chicago, and went and joined the wait. Sat and talked and worked on a crossword puzzle.
Technically, we had made our decision. We knew what we wanted to do. So we had our technical recommendations already in place, and the 70 hours were really just financial negotiations, terms and conditions, a lot of contract talk. But it was emotional.
Then they sort of finally came in and said, well, we need to see you in Jack Pope's office. So we went down there and they said, you've got the deal. I was glad I was there, and it was exciting to be there. My contribution probably can be measured in very small numbers at that point. You know, it was just being there.
What clinched the deal was the agreement put in front of Boeing by Jim Guyette.
So he wrote a handwritten note at 2:15 in the morning saying things like, we agree to work together, you know, really complicated words, to deliver a service-ready airplane, an airplane that works. It has the functionality, the passengers like it, the attendants like it, the maintenance people like it, the flight crew likes it, and we agree to work together to make that happen. And then he dragged Phil Condit and Dick Albrecht into the room, and he said, will you sign this? And they said, and he took that to Mr. Wolf, and he said, this is the new Boeing. The new Boeing is going to treat us at a new level of respect as a customer. The reason I wanted you to know this is that that meeting at 2:30 in the morning has changed my life. And it's going to change yours. I've been waiting for 4 years for you to arrive because it's time to make an airplane.
United Airlines agreed to buy 34 777s for delivery in 1995 and to take an option on another 34 for delivery 3 years later. They had committed to spending $3.5 billion, on a plane that didn't yet exist. The plane United bought would have a number of important features. It would be powered by just 2 large engines. It would be guided by a state-of-the-art electronic control system, and it would be built from the newest and most reliable materials. It would also be a very big airplane. Not quite a jumbo, but not far from it. The diameter of the engine would be as wide as the whole fuselage of a 737, and the horizontal tail would be equal to the 737's wing. But it was the interior of the plane that most interested the customer. To show off the interior layout, Boeing spent hundreds of thousands of dollars on a life-sized mock-up. It would be an essential sales tool. Early on, Lord King, chairman of British Airways, was given a guided tour.
Hello.
Lord King is shown an important area at the back of the mock-up, called by salesmen the dirty pool, with an emphasis on how the 777 would compare with the competition.
So all the wide bodies flying today, because what we were after was, you said make it bigger and make it roomier. Well, this is what people are used to flying. Here's the contour, and here's the bends. Here are the bends. Here's the 777, the 5 inches larger. You can see the contour, and then the effect of the bend. Okay,
All right, let's look at
the back.
In previous Boeing planes, full-scale mock-ups of the aircraft, inside and out, were not just marketing tools. They performed an important role in the design process. With the 747, for example, Boeing built several life-size mock-ups of the whole plane, with every part modeled in detail before the design was finalized. It was the only way the engineers could see whether or not the pieces fit together. Because of the three-dimensional complexity of the plane, a component as first designed often got in the way of the structure or one of the other parts, like these red pipes, which are not meant to go through the yellow duct. With the 777, Boeing wanted to find ways to catch these interferences, as they're called, before the assembly stage.
You have 5,000 engineers designing the airplane. It's very difficult for those engineers to coordinate with 2-dimensional pieces of paper. For a designer who's designing a air conditioning duct to walk over to somebody designing structure and say, now here's my duct, how does it match up with your structure? And they've got 2-dimensional pictures, very difficult. So we ended up using the mock-up and, quite honestly, the final assembly line to finish up the integration. And it's very costly. You end up with an airplane that's very difficult to build.
It all has to do with visualizing 3 dimensions on a 2-dimensional drawing board. One of the trickiest problems was working out the lengths and angles of tubes, pipes, and wires.
We would literally, physically thread the systems through that mock-up, and then, in the wire bundle sense, take it out of the mock-up, flatten it on the board, measure it, and that's the way we decided how long the wire needed to be. And then you would adjust as necessary, because the airplane, not made of plywood and aluminum, differs from the mock-up. So as you produce those first wire bundles, then you make further adjustments to make them fit the real airplane. Hydraulic tube, a very similar situation.
The solution was a secret weapon called EPIC, a computerized design system that would require 8 mainframe computers to run it. Engineers would be able to roam the virtual interior of a plane that didn't yet exist. As pieces were designed, they appeared in the virtual airplane next to other components, and the team could check to see that they all fit together before they were carved out of metal.
So for the first time, the engineering creative process was enabled to think in terms of the way the world is, in terms of 3 dimensions. Now, computers don't design airplanes. We have not put the knowledge that's in the airplane designer's head into artificial intelligence that balances all these objectives. Someday, we'll continue to probably move to that end, but right now, the knowledge to design airplanes is in the designer's head.
There would be more than 2,000 computer terminals so that each group of designers could feed their drawings into the main computers. In June 1992, the passenger doors team was checking for interferences in the components they had designed. An interference showed up in red. The designer was concerned about two crucial components in the door hinge.
This splined part right here, there's a bolt passing through it. It's actually the connection of the door to the door frame, the cutout. And this bolt affects that connection. Somewhere inside there we've broken some law. Now that looks like a real interference. This is what happens when you accommodate your stress man's desire that they be intimate. Ah, they interfere for the entire head of that bolt. But the actual amount it interferes, we really tell by cutting through the two of them and looking at an accurate cut, which doesn't take hardly any time at all. Now this, yes, the second circle is just a little bit larger than the first circle, and I do indeed have a little problem here. But it's a very small one. We haven't released any drawings yet.
Another innovation on the 777 would be a new method of organizing the 10,000 or so people building the plane. On past projects, airplane design had been bedeviled by communication problems between the many different divisions in the company. For the 777, Boeing would create new work groups called Design Build Teams, or DBTs. They would include people who had never before worked together.
I wish that I could say that design build teams were sort of one of those wonderful ideas that sort of leapt forward and you said, aha. In a lot of ways, it is a return to some things that have worked in the past that were scale driven. If you go back to the early airplanes that Boeing built, the factory was on the bottom floor, engineering was on the upper floor. Both manufacturing and engineering went back and forth. When there was a problem in the factory, the engineer went down and looked at it and said, well, you better do this. The entire design department was within 50 feet of each other. As the scale went up, that gets harder and harder and harder. And if you're not careful, organizations, just by the way they behave, want to form little enclaves. So structures goes off over here, and air conditioning goes off over there, manufacturing goes over here, and planning goes over there, and finance goes over there. And then one day you turn around and you've discovered there's an us and them attitude. If only they would do this, then our job would be easier, and if only they would do this.
The passenger doors were designed by one of over 200 design build teams, each responsible for a major component. Making an airplane door that works involves the complex interaction of geometry, materials, manufacturing, and in-service maintenance. At one point, this team faced a problem that brought up all these factors.
That's a full-size drawing of the two cutouts in the door skin that are located very closely together. And again, our principal concern is making sure that with all of the parts that have to be integrated into this area and the fasteners that have to be put in the skin, do we have enough room to do all of that, and will the assembly be durable and damage tolerant?
The problem involved a metal area of the door skin between the window and the door handle cutout that was uncomfortably narrow. The designers have two questions. How strong a force would produce a crack in this area? And if the metal did crack, what force could enlarge it and lead to the door failing? They get two different figures from the stress analysis engineers. It would take a force of 27,000 pounds per square inch to crack the metal. But once a crack had formed, the force of 12,000 pounds would be enough to open it up.
That's the way we perceive the situation. 12 is the upper limit at which the crack will not grow. And in this area, there's not much room for a crack to grow. We're very tight.
I guess the problem, what's still not clear in my mind is, for the identical area under the identical consideration, are you getting a recommendation of 12 from one guy and 27 from another?
Yes, for two different reasons.
Right. And if you follow the first guy, you would in all cases restrict the stress to 12.
Yes.
And the second guy says, as far as he's concerned, you could go to 27, but he's not considering the other requirement.
That's correct.
Okay.
That's correct. We could work it to 27, but if a crack should start, it's going to grow right across the area.
Okay.
If we hold it to 12, it immediately satisfies the other one.
Okay.
That's all we're saying.
There were 4 possible fixes, involving thickening the existing metal or adding an extra layer called the doubler. However, since any cracks would be easily visible, perhaps they could just ask the airline to keep a lookout.
Just call for a special inspection in that area. That's an alternative.
True.
Not pleasant, agreed, but it's an alternative.
Especially since we've already told United we won't have any of those.
That's right. But this happens to be on a door that gets frequently used. The number 4 door is supposed to be one of the most frequently accessed for loading the aft galleys and so forth. It may not be much to have an experienced person show up there every so often and just take a close look instead of having to have something leap out at you and say, I have a crack, I have a crack.
I understand.
It took another 4 months to solve the problem entirely by designing an extra layer called a doubler to go behind the outer skin.
Well, if we just left it a skin without this doubler here, it may be strong enough for static strength, meaning it can take the pressure of the airplane, but over repeated pressurizations, eventually it would get tired, it would fatigue, it would crack, and the crack would then go across here. The airlines would catch the crack, and then they'd have a very difficult maintenance job to go in and repair it, perhaps putting the doubler, maybe one like this, on the outside, which then is drag and etc. So it pays us to figure this all out ahead of time and put it in behind.
In mid-1992, while the team was still designing the door, they built a prototype for a very important cold weather safety test. The engineers wanted to see if the door could be opened in the worst imaginable conditions of icing on the outside of the fuselage. The first stage of the test involved spraying the door with water all night in a low-temperature chamber until there was a thick layer of ice.
Welcome to the Bahamas.
But how could a plane ever get into such a state?
If a plane lands from a cold flight, minus 65, and comes into an airport where, let's say, it's about 28 degrees, there's freezing rain, and it pulls up to the gate, and this freezing rain is then adhered to the outside of the airplane, we need to make sure that we can open the doors. Our criteria is a 1/4 inch thick of ice all over the whole airplane. And yet, at the same time, someone with nominal handle force on the inside can indeed open the door. We consider the ice to be as strong as 100 pounds per square inch to break it. It's a 1/4 inch thick, and there's about 200 or so inches of ice around there. So when you factor all that in with safety factors, it's about 6,000 pounds of lift that has to be put on the door to make sure we break all the ice. And that has to be put in with about 50 pounds of handle force on the inside.
Set up as quick as we can.
The following morning, the door had acquired a thick enough layer of ice to test the mechanism.
It's minus 20 in there right now. It was minus 55 in there yesterday when we sprayed the water to make sure it iced up. Considerably colder yesterday. Minus 20 is not so bad.
This test had never been done before on this door design. If it didn't work, the engineers would have to redesign the complicated opening mechanism inside the door.
Now this is, the girth bar was right against here?
Right, this is all fabric.
That's great.
It'll show up automatically.
Boy, it's nice. This is a big key test, and it worked great. Feel real good about it. Right.
Another part of the plane that was being tested long before the 777 existed was the flight control system. Boeing equipped one of its smaller planes, this 757, with a prototype of a brand new system that would be used in the 777. They had to test it in flight.
Right now I'm holding a lot of column force.
These tests came after many months of testing in simulators on the ground. The new system was called fly-by-wire.
I'll go to 10,000 feet and about 250 knots, and we'll stop there and do some evaluation.
Fly-by-wire is an unfortunate term. Probably electronic flight control system is as close as you can come to the real definition. But it's simply the idea that we use electrical wires rather than mechanical cables to transfer signals from the front end to the back end of the airplane.
Boeing's chief test pilot for the 777 was John Cashman. He would be the first to fly the plane once it was built. He quickly understood the advance that fly-by-wire represented over the more cumbersome system then in use.
An airplane, particularly a large airplane, has large cables that run from the cockpit controls to the actuators that move the surfaces. And almost all big airplanes are hydraulically moving the controls. Those large cable runs are very difficult to rig and very time-consuming to maintain them in rig. So from a maintenance side, it's a fairly big improvement in terms of time to maintain. The changes that one can make and improvements that you can add to an airplane are much easily done if it's a computer card change versus a mechanical redesign.
There's a pilot's joke about fly-by-wire systems that says that modern planes could be flown by a pilot and a dog. The dog to bite the pilot if he touches the controls, and the pilot to feed the dog. In fact, the computer systems that would be installed in the 777 were so intelligent that engineers believed they could make decisions that would be as good as those made by the pilot. But Boeing stopped short of letting computers fly the plane. It was a question of safety.
The biggest disadvantage from a safety point of view is the potential that you haven't thought clearly through all of the events that may occur and taken enough precaution. There's an apprehension anytime you change technology, and particularly when you switch from mechanical, which is visible, to electrical, which is not. And so to some extent, we've taken a conservative approach to make the airplane fly like a conventional airplane from a pilot's point of view.
One of the things that we do in the basic design is the pilot always has the ultimate authority of control. There's no computer on the airplane that he cannot override or turn off if the ultimate comes. But in terms of any of our features, even those that are built to prevent the airplane from stalling, which is the lowest speed you could fly and beyond which you would lose control, we don't inhibit that totally. We make it difficult, but if something in the box should inappropriately think it's stalling when it isn't, the pilot can say, this is wrong, and he can override it. That's a fundamental difference in philosophy that we have versus some of the competition.
The 777's computers, which were being tested on the 757, would translate the pilot's instructions into commands to move what are called the control surfaces, movable pieces of the wing and tail that allow the plane to change direction or altitude. This flight was one of a series to test how the fly-by-wire system felt to a pilot when he landed the plane. Like all testing on this new plane, every aspect of the test would be analyzed and discussed to see what lessons could be learned before the design was finalized. The process began with the post-flight briefing. The The two pilots reported on how the plane felt as they landed it with the fly-by-wire controls.
Well, you're the third pilot now to have an experience like that, not unique to C-STAR-U landings, but simply on various landings reporting that your initial flare input generated a result greater than you anticipated.
You actually do that, you think, oops, you back off, and you always back off too much.
Yeah.
And you end up with a Navy landing.
Uh-huh.
That means a good landing.
Which, by Frank's definition, is an excellent landing.
In early 1992, the team was under tremendous pressure as weight, cost, and design targets had all been exceeded. They scrutinized every aspect of the project, including travel costs for engineers who were flying from Seattle to meetings with subcontractors in other parts of the world.
We looked at the cost of travel. Right now we travel business class. And for my group, the difference between traveling business class and coach with what we project our tests are going to be, testing support and meetings, is something the order of $700,000. Now we're at a stage of the game where I'm not going to piss my guys off and say you travel coach and everyone else travels business class. So what I'd like to propose is that the 777 program proposes that when we go to UK we fly coach. I think we could save a tremendous amount of money.
I have a guy who's fairly big.
Well, I think, and so do I, and I think we can make an exception for that.
And it is very uncomfortable.
Yeah.
For that length of flight and then to carry on a meaningful meeting next day.
But we did this for years and years. It's only in the last 5 years or so that we've started to fly business class.
Why don't you, let's do what Hardy said and pass that and see what kind of reaction you get, and then let's bring it up next time.
It would probably have been unfair to ask if the economy seats in existing planes were too narrow, who designed them, since it was the airlines and not these engineers who decided how many seats to put in a plane. The next item dealt with another thorny subject, office space. With a move to new offices coming up, there was some contention on how the new offices had been assigned.
Some of my supervisors have come in to me about the move to Everett and said they thought that all first-line supervisors are in cubes, but they hear that some first-line supervisors are in offices.
Not in engineering?
Yes. Engineering.
Tell me who they are. Because we worked it so that it was supposed to be
on
that
the
way.
floor that I'm on, there are first-line supervisors in offices, and they're not payloads.
Will you tell me who they are?
I'll write it down for you.
Because they tell me that we fixed it. Alan decreed.
We still owe them engineering.
New terminology came thick and fast at this stage of the project. Too fast for some members of the team.
We do that.
MCs are
Okay. Requirements for SDS items and APL, Raj, next week.
I forgot what an SDS item is.
It's a shop distribution standard.
Okay.
We'll also show you the PRR process
With delivery schedules becoming critical, tempers began to flare when one engineer felt he was being delayed by another.
I've taken a lot of flack over that. Item 8 was the wrong one to put in. The thing that we agreed to put in is when structures returns to data set.
No. My man told me.
No, we all agreed.
We all agreed. Even showed him the chart.
I showed you the chart.
But,
I showed you which
that's useless data. Most of it is obsolete. Because
it's not useless data.
It is.
I'm missing releases because you did not transfer on the date the agreed to information.
Because you didn't transfer to me.
What baloney.
Anyways, that's the wrong date.
No, it's not.
I did it.
Oh, okay.
I sat there for 5 minutes 2 weeks ago and explained it. I showed you an example. Everybody jumped on.
Why are you talking to me? I agree.
You guys agreed?
Yeah.
It's done.
It's done.
In spite of mounting pressures, there was the occasional good news. One of the team reported on a foreign airline whose government was deciding on the purchase of 6 777s. The 777 had been up against its main competitor, the Airbus A330.
And the cabinet had approved the 6. And then they said, well, we think that may not be right. And what we think is we probably ought to add 2 more. So instead of approving 6, they approved 8. And then they also did not approve the 8 A330s. or sorry, 7 A330s that they were asked to approve.
All right. Nothing like winning.
But there was no disguising concerns about the task that lay ahead. They were just 9 months away from assembling the first piece of the first plane.
Roger, do you have anything else?
Yeah, I have something to say. I'm worried about us. I'm worried about our recovery. We're behind schedule, and what I see is it's going to take a long time to recover. And I think we really need a recovery plan. And I don't think we have one.
Okay.
And I'm
Roger
really
was reflecting that we keep telling each other what we really need, and we keep trying to help each other, because in the heat of getting your own stuff out again, the first thing that you let go is coordinating with your, with your colleagues. And Roger is just trying to remind everybody, you can't worry by yourself.
Underlying the building of the 777 was a new kind of organizational philosophy Boeing had dubbed working together. This easily dismissed slogan masked what amounted for Boeing to an internal revolution. For the first time, Boeing would be guided by principles that encouraged, even forced cooperation. First and foremost, there would be no secrets. Information would be shared openly, even when things went wrong.
We had to make some cultural changes. I guess that's the best way to put it. We had to open communications. We had to break down traditional barriers between organizations. We had to come up with forums where the people could speak up, and more open communications and more frankness coming from all levels to management or vice versa.
It was a point of conflict to begin with. You know, an engineer with pride wants to find the solution to his problems. And it's not a natural thing to go out and explore publicly the particular problems you have. You'd like to do it and be able to handle those yourself. So I'd say, yeah, there was resistance at first, but it's interesting what attention can be given to a particular problem like that, communication problem, if you will, in that regard, by just making it okay to do that sort of thing. That the thing to do is to express your problems, get all the help you can. If you're working together, you're going to find that a great assistance in finding the solution, because none of us singularly can do nearly as well as we can as a group. And so I think over the years that's gone away. I think we kind of shout it from the rooftops in our program reviews with large audiences, in our all-team meetings. It's been said, the same words have been used. It's okay. It's almost like celebrate our problems, get them out in the open so we can go work them.
One of the areas of the plane getting a lot of early attention was the interior, the part that would sell tickets. Less visible to the passenger, but equally important, was the design of the cockpit.
The color scheme we kept basic, the same as the 747. And the reason why is because there was a group of people who did a study on color, and they found that warm colors like brown were more inviting to a pilot, and also it kept them more alert. And also we found that brown hid more of dirt than any other color.
But the pride of the 777 cockpit would be the cup holder.
For the coffee cup holder, we come up with concepts first in a drawing, and then we make them out of cardboard. And after we finish our design that we think we like the best, we start casting them. And these are the two that we casted. And so we refine them. So what you have in the flight deck right now is the refined version. And what's also nice, we came up with the idea that it could be removable, because we know that over time that the beverages would spill and stay sticky. You want something that's easily cleanable. And these are some of the samples pop can, styrofoam cups, airline cup, and they all fit. And we also had to take consideration of the height of the handles, just to make sure that it does fit into the holder itself.
Boeing was also proud of its new overhead bins, which seemed to demand a technology and a jargon all their own.
We have 3 sizes of bins, and those bins can be shuffled to any arrangement to sneak up to outboard monuments. We call them monuments, labs, closets, galleys, etc. But more importantly, in the past, each one of those monuments was very static and had to be tied straight back to structure. In this design, this fore and aft member allows that unit to be translated fore and aft in the cabin on 1-inch centers anywhere in the airplane in prescribed flex zones that allow load path capability in the overhead rail.
The Japanese were expected to be one of the largest purchasers of the 777, but would be among the shortest in stature. Nichols finds a diplomatic way to refer to this fact in describing the design process.
This is an issue with our customers, more so with our Pacific Rim customers than for instance, European customers, the American carriers. And it's flat the height, it's the ergonomics of the latch, and some of them feel that it's a bit too high. Now, on a pivot bin, it must be this high to reach the latch, but once it opens, then the access to the bin is more than acceptable and more than appropriate in terms of a shelf bin. Where the shelf bin remains static, you hit a latch that's quite low, and the door swings up, and now I'm reaching up here to grab the door. So the latch handle, though our customers have expressed some concern, they've all been through the mock-up, and they understand our design, and to physically move that's something that would be, demand a lot of effort, and believe me, we can do anything, but we've, if you will, pounded our stake in the ground and believe ergonomically and demographically this is the right latch.
A part of the plane least likely to be the site of technological innovation were the lavatory seats, but Alan Mullally liked to tell the story of the airline that came to him with a problem.
In the lavatories, when a toilet lid or a toilet seat falls down in the toilet bowl, it makes what they called the big hit sound, the big bang sound. And they found that that was very distressing to the traveling public. So we went to work. We got the mechanical designers, the electrical designers, and the toilet suppliers and makers of toilets and toilet lids, and we got them together, and we started to work on a small device that we could put on the back of the toilet lid. You can see this device right here. And this little device could go on the toilet lid, and we could put another piece out the other side that could hook onto the toilet seat. And we could absorb the energy of the toilet lid and the toilet seat before it hit the toilet bowl. So we could slow the lid down, slow the seat down, so that the big bang sound went away. But think how people are going to feel that when they put the toilet seat lid down, it goes like that. They're going to feel like they're in a quality airplane. Now this is a customer-in toilet seat lid.
The first year's work on the 777 involved designing the new plane. Now, manufacturing would get underway. It would begin as the first component of Boeing's brand new aircraft, a wing spar, began assembly on a giant automated riveting tool. This piece was a long, thin metal spar that would run the full length of the wing. Over the next few months, the rest of the wing would be built up around it. Sylvia Lefferer had the informal honor of initiating the process as she began her job of sealing the edges of the 100-foot-long piece before it was fastened to other components. It was a simple process involving an injection gun and compressed air.
Something's wrong.
At least it was supposed to be.
We got a problem. We got no air right now, so we got to try to get that hooked back up. Well, it did for a minute. Maybe it just bled out.
Once the air started flowing, she smeared a layer of gray sealant along the piece. After years of doing this on other planes, she could produce a layer of constant thickness the entire length of the piece. The work had to be checked by a quality control inspector. Too thick a layer would add weight to the plane. Too thin and it wouldn't seal properly or prevent corrosion.
Looks good.
Thank you.
Sylvia's work passed inspection and the pieces were moved into contact with another component ready for fastening. Then there was another small problem. The upper piece of the spar was out of position by a 50th of an inch.
The lower cord's at its locator inboard. The upper cord's 20 thou outboard of its locator.
You mean we just want to index up right there, right?
That's correct.
Couldn't we just take a big C-clamp and tap it in?
You might as well use the provision of the tool, what it was built to do.
Let's go ahead. To move this way?
Yeah.
Okay, I want to see it. I haven't seen it.
That's what this ratchet handle does here. See, you clamp this here, and then just hopefully move this upper cord inboard.
You ready?
You ready? Ready? Okay. Good. Now watch.
Over in the 777 team's brand new office building, Alan Mullally arrived for work. It was just a few days after Christmas. Mullally hadn't had much of a holiday.
But I came in on all but 2 days. But it was kind of a nice time. It was almost like a time to kind of reflect on the past year and think about the priorities for '93. We had quite a few people working, especially in engineering and in operations and planning and tooling, where they were supporting the first parts of assembly. So I talked to quite a few of the structures engineers and the planners and the toolers associated with structure, just to get a feeling for how they saw it, what their problems were, and challenges and stuff.
Although the team had started assembling the wing, the design of the plane was not finished.
But really, the way we lay out the program is that we stretch that process over nearly 2 years. So what determines what parts are going to be designed is the sequence of when it's going to be assembled. So the actual designing of all these parts is spread over 2 years. So even though we're seeing parts being assembled for like the front spar, those are the parts that were designed first, because those are the parts that need to be built first. But right now, all the payloads area, like all of the bins and the seat tracks and stuff, they're just being designed now because they'll go into the airplane later in the sequence.
The beginning of assembly was a significant milestone in the life of the 777. But now there were only 18 months till a piece of metal in this tool would fly, along with 4 million other components, on the airplane's first flight. And as Mullally looked ahead, he and his team faced an ongoing recession in the aviation industry. How would this affect the fortunes of Boeing's new plane?
It's so important for us that we absolutely not let the current events affect our intensity on getting this program done, because this is such a long-term business and these projects are big and they're made for the future, that we just can't let the anxiousness and the ambiguity of today's environment in any way slow us down. And so we talk about it. We talk about it openly. We talk about every cancellation. We talk about every airline that gets in trouble, every airline that has to go into Chapter 11, bankruptcy, and what it means to Boeing. And we talk about what's happening to Airbus the same way and what it means to us. And it's okay. It's really important that we talk about it. And then we move on to what our real job is, and that is stay focused on developing the airplane for the future. And that's our strength to keep going. But it is worrisome.
The team's morale was at a low point. But there was no stopping the plane-making machine that had lumbered into action. They were committed to building the 777 whatever the challenges, and there were certain to be more of those in the months ahead.